So today our group will present about application Gauss-Jordan elimination. Before we go through, I will explain first about introduction of Gauss-Jordan. First, what is Gauss-Jordan elimination? Gauss-Jordan elimination is a systematic method used in a linear algebra to solve system of linear equations. It involves transforming matrix into reduced row echelon form using elementary row operation. This process eliminates all non-leading entries above and below each pivot, which is leading one in matrix. Second, we talk about when the Gauss-Jordan elimination can be used. Gauss-Jordan elimination can be applied when to solve a system of linear equation and to find the inverse of any invertible matrix. Next, how is Gauss-Jordan elimination will express? The method is carried out using elementary row operation on an augmented matrix representing the system of equations. This operation include row swapping, which is interchanging two rows. Second, row multiplication, which is multiplying a row by a non-zero scalar. Third, row addition, adding or subtracting multiple of one row to another row. The goal is to convert the matrix into reduced row echelon form, which is RREF, which look like this example. As you all can see, above and below leading one is equal to 0. So that we can conclude this clearly show the solution to the variable x equal to a, y equal to b, and z equal to c.
Thank you for my friend Arfan for the explanation of the introduction. Now we're moving on to the purpose of the study. So the purpose of the study is to solve the system of linear equation efficiently by converting matrices into reduced row echelon form. We call it as RREF. And other than that, the purpose of the study is to understand and apply elementary row operation in matrix transformation. Furthermore, to determine the number of unit of each product that can be produced under machine time constraints. This is the purpose for our case study case. And last but not least is to illustrate the practical use of linear algebra in industrial and manufacturing setting. So we are focusing in the industrial and manufacturing setting by using the Gauss-Jordan elimination method as a way to settle the problem. Moving on, now I'm going to talk about the Gauss-Jordan elimination. So the Gauss-Jordan is an extension of Gaussian but with similar steps. The only difference is, in this method, the augmented matrix is reduced to reduced row echelon form matrix, which we call it as RREF. So what is RREF? Reduced row echelon form matrix is a form when all entries below and above the leading one are all zero. So as example here, where I collect it from Google, we can see that all the leading one above the leading one are all zero. Above and below, my apologies. As we can see, the first example, the leading one is 1, and the upper and below, above and below it is 0. And we can go to the second row. The leading one is above and below the leading one are also 0. But it doesn't mean that the number beside it, for example, the number beside the leading one is 3. It doesn't need to be 0 in the above and the below it. So as we can see for the other example, this is the example of RREF, and that's all.
So we move to the problem statement. A small factory produces 3 products, which is A, B, and C. Each product requires a certain number of hours on 3 machines: machine 1, machine 2, and machine 3. So look at the table, and the question is, how many units of A, B, and C can the factory produce without exceeding machine times?
Alright, next we are moving on methodology or how to solve the problem.
First of all, step 1, we need to form the system of equation. Let x equals to units of product A, y equals to units of product B, z equals to units of product C. Next, we form the real equation, which is 2x plus y plus z equals to 10. The second equation is x plus 3y plus 2z equals to 15. And the third equation is x plus 2y plus 3z equals to 18. Next, the second step is we write the equation into the augmented matrix. Step 3 is we solve the question using Gauss-Jordan elimination. The first step of Gauss-Jordan elimination is after we settle the augmented matrix, we need to transform the matrix into the RREF form, which is identity matrix. First of all, we need to interchange row 1 and row 2. And the answer will be 1, 3, 2, 15, 2, 1, 1, 10, 1, 2, 3, 18. Next, row 2 minus 2 row 1 will be the new row 2. And we combine the process with row 3 minus row 1 and it will be a new row 3. So the answer will be 1, 3, 2, 15, 0, negative 5, negative 3, negative 20, 0, negative 1, 1, 3. The next step is we need to multiple row 2 with negative 1 over 5. And we will get 1, 3, 2, 15, 0, 1, 3 over 5, 4, 0, negative 1, 1, 3. The next step is row 1 minus 3 row 2 and it will be the new R1, which is row 1. We combine the process with row 3 plus row 2 and it will be row 3. The answer that we will get is 1, 0, 1 over 5, 3. And for row 2, 0, 1, 3 over 5, 4. And for the row 3 is 0, 0, 8 over 5, 7. The second last step is we need to multiply row 3 with 5 over 8. And we will get for row 1, 1, 0, 1 over 5, 3. For row 2, 0, 1, 3 over 5, 4. And for row 3, 0, 0, 1, 35 over 8. And the last step also, we combine the process, which is row 1 minus 1 over 5 row 3 and it will become the new row 1. And the second process is row 2 minus 3 over 5 row 3 and it will become new R2, which is row 2. And we will get the answer in augmented matrix, which is in identity. 1 for row 1, 1, 0, 0, 17 over 8. Row 2, 0, 1, 0, 11 over 8. And row 3, 0, 0, 1, 35 over 8. That is for row 3. And we can conclude that the answer for the equation is x equals to 17 over 8, y equals to 11 over 8, z equals to 35 over 8.
So for the result and discussion, this is the maximum number of each product that the factory can make using the available machine hour exactly. So for product A is equal to 2.125 units, for product B 1.375 units, and product C 4.375 units.
So as the conclusion for our video, first we talk about what is the conclusion from this problem. Based on the problem statement, we can conclude that using Gauss-Jordan elimination method process allow us to decide whether a system has a strictly defined answer, an infinite number of answer or none at all. It's done by using row operation, which is swapping rows, scaling and addition one row to another, in order to simplify the system row by row until the answer is obvious. Lastly, what we learned? Through Gauss-Jordan elimination, we learn more about the form of linear system and the solution they possess. It show us how to write the equation in metric form and present to us some important concept, which is linear dependence, consistency and matrix rank. This approach not only help in the solution of equation, but also form the basis of more advanced linear algebra and other topics. That's all for our group. Thank you.